Alright, now let's talk about generics in TypeScript. Generics let you write reusable code that works with different data types without sacrificing type safety. So instead of writing multiple versions of the same function or class for different types, you write one version that works with any type. Generics is all about making your code more flexible and reusable. They work with functions, classes, and interfaces. Let's look at a generic function example. Let's imagine for a second that we want to create functions that return values of different types. Here we have two functions, print string and print number. Print string accepts an argument of type string and returns a string value. Print number accepts an argument of type number and returns a number value. And we're simply logging the values to the console right here. But what you would notice is that these functions are doing exactly the same thing. So why not create one function that can accept or work with any data type instead of repeating ourselves as we are currently doing right now? So I'm going to go ahead and save the code and run it. Alright, and of course, as you would expect, here we have hello and 1, 2, 3. I'm going to clear the output, close, and let's see how we can define a generic function. Alright, so here we have a generic function, print value of any type. Okay, the letter T is a placeholder for type. We are basically saying that this function can accept a single argument of any type or type T, if you may, and return that value. Now, T in itself does not mean anything. It's just a placeholder. You could also use any letter in the English alphabet, A, B, C, whatever letter you want to use. So here we're calling the function and passing a string value. Here we're calling the function and passing a number or numeric value. And here we're calling the function passing a boolean. Let's go ahead and execute the code. We have our values printed for us right here. Now let's take a look at a generic class example. So here we have a generic class box of type T. Type T is just a placeholder, and here we have a private property content of type T, and inside the constructor we initialize the content. Here we have a method that returns the value of content. Let's go ahead and instantiate our box class with different values. We have created two instances of the box class. Here we initialized it with a number, and we're simply logging the content to the console. And here we initialized the box class with a string and logging the content to the console. So I'm going to click the play button to run it. And right here we have 1, 2, 3 and hello, and there is how you define a generic class in TypeScript. Let's look at generic interface. All right, and that is how you define a generic interface in TypeScript. Now let's go ahead and use our generic interface to create an object. So when using the post interface, we must specify the type of data. Okay, if I go ahead and remove the string type right here, we get a squiggly underline, and the problem is generic type post T. Remember, T is a placeholder for a data type, requires one type argument. Okay, and we have not provided it. And you might be wondering what would happen if I just type T here. Well, T is nothing. T is not known to our code. As you can see, TypeScript says here cannot find name T, because T is nothing but a placeholder for type. So I'm gonna go ahead and say that this must be a string. All right, but what if our content could also be an object? Of course it could. So all we need to do is replace the string with an object type, and then of course we need to update the code. So here I'm gonna say P, let's say is it's a paragraph. There you have it. Now let's go ahead and talk about generic constraints in TypeScript. All right, by default generics accept any type, but you can restrict them to a number of types. This way we can prevent invalid input while keeping the function flexible. Let's go ahead and take a look at how to define a generic function with constraints. All right. So here we have a generic function with constraints. Here we are using extends keyword, which you might be familiar with in object-oriented programming when working with inheritance. So what we're basically saying here is we don't know what a type is, okay? So again, we're using a placeholder t. However, we are saying even though we do not know what a type is, we are certain that the type must have a length property which must be of type number. And here we defined our parameter of type t, and we are simply saying here that this function is not returning any value, hence we put void. And within the function body, we are simply logging the length of the item to the console. So here, as you can see, the code is looking perfectly fine, and here as well, because this is a string and it has a length property which returns the number of characters in that string. And here we have an array of numbers. Arrays in JavaScript have length property which returns the number of elements or items in that array. Unfortunately, booleans do not have a length property, and as you can see right here, argument of type boolean is not assignable to parameter of type length number. Okay, so what this is basically saying is that true does not have a length property. So I'm going to go ahead and comment out that line. Let's save the code and run it. And here we have length is 5 and length is 3, and that is generics in TypeScript.